All right, welcome back. So we are considering memory, storage devices, and media. Memory, storage devices, and media. Memory, storage devices, and media. So and there we shall be looking at the primary storage, the secondary storage, and the offline storage. The primary storage, the secondary storage, and the offline storage media. Offline storage media. Now, memory and storage. Memory and storage devices can be split up into three distinct groups, and they are primary memory, secondary storage, and offline storage. Primary memory, secondary storage, and offline storage. Primary memory, secondary storage, and offline storage. So let us consider this figure, which is figure 6.3, which shows how these all link together. That is, the primary memory is linked to the offline storage, okay? The primary memory can as well be linked to the secondary storage, and the secondary storage can be linked to the offline storage. I repeat that. The primary memory can be linked to the offline storage. The primary memory can be linked to the secondary storage, and the secondary storage can be linked to the offline storage. And what do I mean by storage? It means where you store your information and files on the computer system. So storing your information and files on the computer system is necessary so that you can retrieve those information later, or when you need the information later, you can go back to it. So it is one of the criteria in designing a computer system. It must have a memory capability, okay? So, and that's one of the standard why designing a computer system. So under the primary memory, we have the RAM, the ROM, that's RAM and ROM. RAM, which stands for the random access memory, ROM, which is the read-only memory. And under offline storage, we have DVD, the CD, the DVD RAM, the Blu-ray disc, the USB memory disc or flash memory, the removable hard drive. And under secondary storage, we have the hard disk drive, that's HDD. Then we have the solid state drive, SSD. So let's consider the primary memory, number one, which is RAM. You can see the image of RAM, okay, as I'm sharing. So RAM, which stands for random access memory. The features of random access memory, RAM, okay. One, it is volatile. That is, it is a temporary memory. The content of the memory are lost when the power to the RAM is turned off. It means when the power to the memory location is turned off, then you lose the content. So it is a temporary memory storage. It can be used to store data, to store file, or part of the operating system that are currently in use. And it can be written to or read from, and the content of the memory can be changed. So in general, the larger the size of RAM, the faster the computer will operate. It means that when you are choosing a computer, for example, you want to buy a computer, you must know the capability of the RAM. Okay, the RAM will be determined by how fast the computer will load. Okay, and how the computer will perform operation in a microsecond or milliseconds. Okay, that's why you have some computers are faster than some others based on their specification and RAM capability. So RAM never runs out of memory, it continues to operate, but it just gets slower and slower as the RAM becomes full It means that when the RAM is full, it's just like when the storage location of your mobile device says your mobile phone is full. Okay, you may be having challenge downloading, and at times it may even happen that call will come and you won't be able to pick the call. You will not even see the call and the phone is ringing. It means that you have almost exhausted the memory location of your mobile phone. So it is also applicable to computer system. You can exhaust the memory location, you understand, by loading too many videos and all of that. Okay, just like what I do on my computer, I only save important files that I will need immediately. You understand? So I don't download videos and keep it on my system. No. If I download any videos, I keep it on my external hard drive. Okay. So that's secondary storage. Because if I should keep the videos on my computer, okay, to take more storage, and with that, it may slow down my system. You understand? So the processor has to continually access the hard disk drive to overwrite old data on RAM with new data by increasing the RAM size. Okay, RAM is much faster to write to or read from than other types of memory, but its main drawback is its volatility. That is, it is a temporary storage location. And we have types of RAM. We have the DRAM and the SRAM. DRAM, which stands for dynamic RAM, SRAM, which stands for static RAM. Dynamic RAM and static RAM. Dynamic RAM and static RAM. So dynamic RAM chip consists of a number of transistors and capacitors. Each of these parts is tiny since a single RAM chip will contain millions of transistors and capacitors. So dynamic RAM consists of both capacitor and transistors. Remember that we said RAM is a memory location. Okay? This type of RAM needs to be constantly refreshed. That is, the capacitor needs to be recharged every 15 microseconds. Otherwise, it will lose its value. Now, for DRAM, DRAMs have a number of advantages over SRAM. They are much less expensive to manufacture than SRAM. Okay? Much less expensive to manufacture. They consume less power than SRAM. They have a higher storage capacity than SRAM. So as you can see, as I'm showing the image of DRAM and SRAM. Okay? So DRAM is less expensive, which is the dynamic random access memory. And the other one is SRAM. Welcome back. The other one is SRAM, which is static random access memory. A big difference between SRAM and DRAM is that this type of memory does not need to be constantly refreshed, just like the DRAM. So we are considering memory and data storage. Memory and data storage. Okay? So welcome back. So you can get back to the video so that you'll be able to start from where I started from. Okay?
Sir.
Pardon?
Sir.
Pardon?
Sir, can you send the video again? I don't get the video.
No, the first one is already on WhatsApp. Okay?
Yes, I'm not. Did not get it.
And no problem. You can chat me later. I will resend it to you personally. Okay? Okay.
Sir.
So, and this one as well, I will also send the video of this class so you can watch it at your leisure time. So, static RAM, the big difference between SRAM and DRAM is that this type of memory does not need to be constantly refreshed. It makes use of flip-flops, which hold each bit of memory. You understand? You know, the DRAM uses capacitor and transistor, but not for the SRAM, which is a static RAM. DRAM is the most common type of RAM used in computers, but where absolute speed is essential. Okay? So then SRAM is the preferred technology. For example, the processor memory cache is the high-speed portion of the memory. It is effective because most programs access the same data or instruction many times. By keeping as much of this information as possible in SRAM, the computer avoids having to access the slower DRAM. So what we are just considering here is how your data or file is being stored on the computer system, which is necessary, okay? And that's what makes up a computer system. Then let's consider ROM, which is the read-only memory. The read-only memory can be summarized as follows. They are non-volatile. You know, the RAM is volatile. So the ROM is the opposite of the RAM. So the ROM is non-volatile. That is, it is a permanent storage location. The content of this memory remains even when the power to the ROM is turned off. They are often used to store the startup instruction when the computer is first switched on. So your ROM is responsible for your computer to come up. The data or contents of a ROM chip can only be read and they cannot be changed. Application. We will now consider an application other than the computer where both RAM and ROM chips are used. Where both RAM and ROM chips are used. Good. A remote control toy car has a circuitry which contains both RAM and ROM chips. The remote control is a handheld device. Of course, we know remote control. We will consider the function of each type of the memory independently. ROM stores the factory settings such as remote control frequencies, that's for ROM. Store the startup routine when the toy car is first switched on, that's for the toy car. When you switch it on, then a signal will be sent to the remote control in order to control the car to move up and down, left and right, and the lights. So the set routines, for example, how the buttons on the handheld device control turning left, acceleration, stopping, and so on. Okay, it means that there is a storage location on how the toy car should move on the remote control, which is embedded as a chip. That is microchip. RAM, the user may wish to program in their own routine. This new instruction will be stored in the RAM chip. The RAM chip will store the data instruction received from the remote control. Now, we have activity which says, describe how ROM and RAM chips could be used in the following devices: a microwave oven, a refrigerator, okay, a remote control model aeroplane. The movement of the aeroplane is controlled by a handheld device. Okay, that is, as we have for toy car, we can as well have aeroplane in form of toy. So that is for primary storage. All right, so let's proceed for secondary storage. Let's proceed for secondary storage, which is the hard disk drive. Of course, you are familiar with hard disk drive, that's HDD. Are probably still the most common method used to store data on a computer. Data is stored on a digital format on the magnetic surface of the disk, or platters, as they are frequently called. The hard disk drive will have a number of platters which can spin at about 7,000 times a second. So what I want you to understand here is that this hard disk drive, it is a storage location. Data is stored on the surface in sectors and tracks. Look at the image that is shown, okay? A sector on a given track will contain a fixed number of bytes. Unfortunately, hard disk drive have very slow data access when compared to the RAM. Okay? Now, many applications require the read-write head to constantly seek for the correct blocks of data. This means a large number of head movement. The effect of latency then becomes very significant. Latency is defined as the time it takes for a specific blocks of data on a data track to rotate around the read-write head. Welcome. So users will sometimes notice the effect of latency when they see messages such as "please wait" or "at its worst, not responding." So the hard disk drive is also responsible for this. Then we have the solid state drive, SSD. Now, latency is an issue in HDD as described earlier. So SSD remove this issue considerably. They have no moving parts and all data is retrieved at the same rate. They don't rely on magnetic properties. The most common type of solid state storage devices store data by controlling the movement of electrons within NAND chips. It means that this SSD use NAND chips and the data is stored okay, as zeros and ones in millions of tiny transistors within the chip. This effectively produces a non-volatile rewritable memory. So we now have number of SSD, which are the EEPROM, which means electronically erasable programmable read-only memory, EEPROM, and which uses NAND gates. Let's look at benefits of SSD. Okay, so what are the main benefits of using SSD rather than HDD? They are more reliable. Yes, they are considerably lighter. They don't have to get up to speed before they work properly. They have a lower power consumption. They run much cooler than HDD. Yes, because they have no moving parts, they are very thin. Data access is considerably faster than HDD. It means SSD is faster than HDD. The main drawback of SSD is the questionable longevity of the technology. Most sorry. Sorry. So most solid state storage devices are conservatively rated at only 20 gigabyte write operation per day over a 3-year period. This is known as SSD endurance. For this reason, SSD technology is not used in servers, for example, where a huge number of write operations take place every day. However, this issue is being addressed by a number of manufacturers to improve the durability of these solid state systems. Offline storage, okay? CD, that's your compact disc, your DVD, where you can store your information. You can actually buy empty disc and store your information there, like movies, videos, and all of that. You understand? Blu-ray disc, optical storage system, USB flash memory, that's your flash drive, your SD card. You can as well save information. So that's offline storage. Removable external hard disk. You understand? I've talked about that. So you can store your information there. So and we have the CD and DVD disc. CD and DVD are described as optical storage devices. Laser light is used to read data and to write data in the surface of the disk. Okay, let's move on. Both CDs and DVD uses a thin layer of metal alloy or light sensitive organic dye to store the data, as can be seen in figure 6.9. You can see this figure. It's an example of CD. The data is stored in pit and bombs on the spiral track. A red laser is used to read and write the data. CDs and DVDs can be designed R, write once only. RW can be written, that is read write, written to and read from many times. So DVD technology is slightly different to that of CD. One of the main differences is the use of dual layering, which considerably increases the storage capacity. Basically, this means that there are two individuals recording layers. Two layers of a standard DVD are joined together with a transparent polycarbonate. Okay? You can see the image of the polycarbonate. Then we have the DVD RAM, the Blu-ray disc, you understand, which work with Trask. So the Blu-ray discs are another example of optical storage media. However, they are fundamentally different to DVDs in their construction and in the way they carry out read-write operation. So that is the Blu-ray disc, which is a blue laser rather than a red laser, is used to carry out read and write operation. Okay, so let us now consider main differences between CDs, DVDs, and Blu-ray. CD, what color? Laser color, red. DVD, red. Blu-ray, blue, as the name implies. Wavelength, 780 Newton per meter, 650 Newton per meter, 405 Newton per meter. This construction, single 1.2 nm polycarbonate layer. Okay. So for DVD, two 0.65 nm polycarbonate layers. Then the track pitch, distance between track, that's 1.60 micrometer. So the future of optical media, okay. In recent times, both the CD and DVD are showing signs of becoming obsolete. Yes, many computer systems now comes with USB. They now come with USB, that's many computers, only and no DVD or CD drive. The main method of transferring files between devices has become the flash memory. Many people now store all their music in the following ways: on hard disk drive, like I said, in MP3 format, on a computer, mobile phone, portable music player, using cloud to store your information, by streaming and all of that. Okay, instead of saving it on your computer system. It is also a similar story for movies where streaming is becoming increasingly more common. Many television sets are now set up as smart TVs. This means it is now possible to stream movies or television programs on demand without the need for any DVD or Blu-ray players. You understand? So in effect, the television set has become the central computer with a link to the internet using wireless connection. Okay, with the aid of your smart TV, which can be connected to the internet. Floppy disks met the same fate in the early 21st century. How often do you see floppy disks nowadays? You understand? You know, nowadays, disks are not common. You understand? So it is very likely that CDs and DVD will meet the same fate and will be replaced by one of the systems described above or something entirely new. Then we have USB flash memory. That's your flash drive and your SD card. Okay, it is also a storage location. You can as well save your information there. So memory stick or flash memory, also known as pen drive, use solid state technology. You can see the image. They usually connect to a computer through the USB port. Yes, use your USB port to connect your flash drive. Their main advantage is that they are very small, lightweight devices, which make them suitable as a method for transferring files between computers. Okay, so complex or expensive software such as an expert system often use memory sticks as a dongle. The dongle contains additional files which are needed to run the software. Without this dongle, the software won't work properly. It means that, for example, on a system that has no Bluetooth configuration, you can buy a Bluetooth dongle in order to have Bluetooth capability, so that a system can have Bluetooth capability. So each memory card is made up of a NAND chips, and as with all solid state memory, there are no moving parts. So you can explore on this. All solid state memories need to be treated with some care if they are removed from a device before being made safe while still in the middle of a read-write operation. Data on the memory card or stick can be corrupted in extreme cases. The memory card or stick become totally unusable. It is essential to wait for the message. It is now safe to remove your device if plugged into the computer. With mobile phones or digital camera, it is usually advisable to switch them off before removal of the card.